Hello, everyone. I am at home today with a sick baby, and so we will be doing our notes today via this video. And it's like I'm there, but I'm not. So today's notes are going to be on density, and these are in Unit 1, and they are target 1.12. So density, what is it? It is a comparison of how much matter there is in a certain amount of space. Now, I know we haven't really talked about matter yet. That's actually in Unit 2, but if you remember maybe from a past science class, matter is just anything that has mass and takes up space. And density is a measure of how much matter there is in a certain amount of space. And there are two main units for density that we'll use in this class. The first one is grams per centimeter cubed, and we'll use that one for solids. And we also have grams per milliliter, which is the unit that we use for liquids. Now, really, density can have any unit as long as it's a mass over a unit for volume. And so these are the ones we're going to use in chemistry most often. And when we do our density lab tomorrow, we will find the density of a solid and use the first unit. And we will also find the density of two different liquids, and we'll use the second unit. So we'll use both of these units. And we'll get to where those units came from in just a second. But let's do two examples about which one is more dense. So first, some non-chemistry examples, because density is really something that we use across all sciences and even outside of science. So here in example 1, you can see that we have two different boxes. And these boxes are occupying the same amount of space because they have the same area. But the box on the left only has 5 dots, and the box on the right has, well, more than 5. And so because density is a comparison of how much matter there's in a certain amount of space, because here we have the same amount of space, the one that has more matter in that same amount of space is going to be the thing that is more dense. Now this could be something like the one on the left could be maybe aluminum compared to the one on the right, which might be lead, because lead is more dense. It has more stuff in the same amount of space. It would feel heavier to you. It could also be comparing something like population density. So maybe the one on the left is where the houses are in like a farm, farmland, and the one on the right is where the houses are in a neighborhood where they're closer together. And the neighborhood would have a higher population density. All right, example 2. So example 2 here, we have 2 more examples of matter. And on the left, we have 5 dots, and on the right, we also have 5 dots. But you can see the one on the left has a much smaller space. So even though we have the same amount of matter, since we have a smaller amount of space, the example on the left would then therefore be more dense. So those are some non-mathematical examples of density, but let's talk about how we're going to use some math with density. So we're going to have one main equation that we use for density, and that equation is D equals M over V, where D is density, M is mass, and V is volume. Now this equation would work great if we were solving for density, but oftentimes we're going to have to solve for the other variables as well, and so we need to be able to manipulate this equation in order to solve for any variable. So if I wanted to solve for mass, so if I wanted to solve for the M, right now M is being divided by V, and so I could solve for M by just multiplying by V on both sides. And so my second density equation might be that mass equals density times volume. Now, let's say I wanted to solve for volume, and right now volume is being multiplied by density using that second equation. And so in order to solve for volume, I would have to divide both sides by density. And so I could use a third equation that volume equals mass over density. So those are the three different equations that I could use. Now, where do our units come from? Well, if we take that density equals mass over volume, then there's where my two units for density come from. Mass divided by volume. And remember, that's what we use for a solid. Or I could also use mass divided by volume if I'm talking about a liquid. So as you can see, the unit that we're going to use most often in chemistry for mass are grams. And that's because we're going to use small samples of things. We don't need to use a kilogram of silver when we are doing an experiment. We're going to use a small amount, 2 grams maybe. And so gram is going to be our unit that we use for mass most often, and it is abbreviated by a lowercase g. Now for volume, if we're talking about a solid, we might have a cube, right? And we would be using small solids. And so each side of the cube might be in centimeters. And if I'm finding the volume, I'd be doing centimeters times centimeters times centimeters, right? Length times width times height. And therefore, my unit for volume might be centimeters cubed. Because remember, whenever we multiply exponents, we really add them, and 1 plus 1 plus 1 is 3. So we would end up with centimeters cubed for our volume. Another way that we could get volume is if we're taking the volume of a liquid, in which case we'd be using one of those pieces of lab equipment we talked about last week, which were the graduated cylinders. And graduated cylinders measure volume in milliliters. And so here we might have our units for volume be milliliters. Therefore, you can see where our two units of density come from. If it's mass divided by volume, G divided by centimeters cubed, and also grams divided by milliliters if we're talking about liquids. So that's where all of our units are going to come from. And that's a good way to identify what information is given to us in the problem. Okay. Now, let's say that you really struggle with manipulating these equations. I have a little cheat for you, which would be the density triangle. So in the density triangle, we would divide it into the 3 parts. So there's our triangle. And then we have our different variables. So we have mass, density, and volume. So this is hard for me to kind of do here without being able to cover. But let's say that I was solving for density. Then density equals mass divided by volume, because here you can see that the M is over the V. If I was solving for mass, for example, then you can see that the D and the V are next to each other, which we would multiply, and that's where we get the equation for mass. And last but not least, if we have volume that we are solving for, you can see that we have M over D, which we would divide. So volume equals mass divided by density. And so this density triangle can really help you arrive at these 3 equations without really understanding the algebra. So that might be a nice little cheat for you to write at the top of a quiz or a test in order to help you manipulate those algebra expressions a little bit more. And because I am too cheap to pay for the paid version of Screencast-O-Matic, this concludes our part 1 video. And so now you need to click the link for part 2 to get to the examples.